Hey everybody, welcome back to your Donna Drones podcast. I'm Dawn Zolda, your host and the CEO of P3 Tech Consulting. We are in a month dedicated to this theme of crossover technologies. Now, when you think about crossover, we're talking about dual use technologies that can be used on the military and commercial side both. This was sponsored by Kongsberg Geospatial, and today we have a company that's been killing it in both markets, Airgility, and we've got Pramod Raheja. He is the CEO, the designer, inventor of some really cool drones and software. The software is what it's all about, people, and we are going to get deep into this today. So Pramod, welcome back to the show.
Thank you. Thanks for having me, Don.
Absolutely. I say welcome back because Mo's been a friend to this show. He was on, I believe, last year during Diversity Month, if I recall correctly. And, he's also a CareSoft partner working with them. But Mo, for those that don't know you, can you give us a little bit about your background that kind of led you to where you are today?
Sure. Thanks, Don. Yeah. So I think, people always say, how did you start Agility? I think it goes way, way, way back to being, I don't even remember, 4, 5, 6 years old and having just about anything that could fly was on my wall in my bedroom. And then fast forward to teenage years. My heroes were the astronauts and test pilots of yesteryear, which led me to study aerospace engineering in college, become a pilot, and essentially I've been around aviation and aerospace my entire life. And so, kind of as we go into the revolution that we know as uncrewed systems, it's a natural fit. And so. I co-founded Airgility with my partner about 6 years ago, who was developing some of the IP that we have right now in the university setting, academic setting, and it was a nice fit, nice marriage of we'll call business and engineering together to form Airgility.
If memory serves, Mode, we're talking about University of Maryland, right? You're a crab. Right. You're a crab.
Actually, we're terrapins. We're turtles.
Oh, that's right.
But we like crabs. We eat crabs.
You do love crabs,
yeah.
And I know you've been involved in the Maryland big pavilion at AUVSI Exponential. Kind of a couple years running. So that's right, the terrapins. Anyway, that's so funny. I want to talk about what Airgility is all about, and a picture paints 1,000 words. So let's roll this video first.
Sounds good. So yeah, you'll see here in a second what we do. We essentially build technology that can fly anywhere, including GPS denied environments, with very easy to use UI UX interface that makes it easy to train anybody. One of the things we hear from both dual use, and we talk about dual use prospects and clients, both in the government and the commercial sector, is that they can't find really good skilled pilots. And to fly in an environment like you're seeing on the screen where you're in a silo and there's dust and things like that, and you're trying to fly first person view, would be absolutely impossible without some autonomy. And so here we're flying in essentially, again, confined, complex environments, can be indoor, outdoor, with autonomy built in, meaning that the drone is actually doing some things autonomously. You're essentially just pressing buttons, as you see on the screen, with a very simple to use UI UX. I would challenge anybody with our UI UX in terms of ground control stations. Also, the ability to fly autonomously through openings such as doors and windows and things like that you're seeing on the screen right now, where really, again, you don't have to do anything other than get it through the door just autonomously. Here, we're able to put Edge AI on board. What you saw there was identifying a target or an object of interest. In this case, it's a person with a gun from in a security type of setting where the drone sees that and says, okay, I'm going to notify somebody. I'm going to go there and check it out a little further. And it's doing this all by itself, essentially. And then, you, the human operator, can, of course, take over and do whatever you need to do. In this case, the AI is essentially flagging the object of interest. And then I think many people think we only fly indoors, but we can fly anywhere, including outdoors in complex environments like you see in the forest here under a tree canopy. Don't need GPS signal to keep us going. And it does perform fairly well in indoor and outdoor conditions there, including wind, any kind of lighting condition as well. So that's the software we build, the algorithms and the software that we build that we have put on our drone, but essentially we could put on other drones as well. And that is our goal, is to take our software and essentially be able to have it as an extra operating system or another layer on top of your flight control software.
Wow, that is so cool. And I just remember not only seeing your drones like in person, but I think it was last September at the Government Business Executive Forum's Edge series in the Washington, D.C. area mode, where you had your team in Maryland doing essentially a live demo. It was remote, but it was live of was it the Minotaur that was flying around?
That's right. And that's just what we saw on the screen. That's our Minotaur. That's correct. Yeah.
Yeah, that was, I mean, it just impressed everybody. And, you can't really emphasize enough the idea that your software enables GPS denied flights, because all you have to do is pick up the paper. Not that anybody reads them anymore. Let's just say scroll through your digital news sources and see that GPS is getting attacked routinely overseas, whether it's Ukraine, Israel, so to be able to operate in GPS denied, and that includes indoors. I don't think most people appreciate that even places like greenhouses, GPS doesn't work in there because the glass reflects the GPS satellite beams, if you will. I know that's hyper scientific for the engineer that I'm talking to, but there's some people out there that can relate more on my level. But super cool. This is award-winning technology, and I'd love for you to talk a little bit about some of the achievements and recognitions that you've racked up, kind of over time.
Yeah, absolutely. So one thing we're very proud of is we were part of the first ever U.S. Air Force Labs accelerator program a few years ago, early as we started the company through an organization called Mass Challenge, and they partnered with the U.S. Air Force to pick 10 companies in their initial cohort out of 400 eligible companies that were part of the AFWorks group at that time, and we were one of the 10. And so that was a big deal. That kind of helped us also launch us into the ecosystem of the government and how the innovation ecosystem works there, and really kind of get us into that. As well, we were selected to demonstrate some of what you saw on the screen there in more austere settings for both the Pentagon and Israeli Ministry of Defense, who did a joint exercise about a year ago near Tel Aviv. And so we were one of just a few companies picked to go over there and do that. And so that was a big deal for us as well, to be recognized in that type of setting with really people who are aware of all the best technologies in the world, and then sort of short selecting us to be part of that group.
Well, the use cases on the military side are really endless. I mean, you had some examples, I think, in that video that translates well kind of onto that battlefield or austere condition type environment. But, I've been obviously following you, Mode, and keeping in touch. And I remember you also went to Australia and you had a lot of meetings there. Now, was that more on the military side, the commercial side, or both?
It was a little bit of both. I think one of the things that we learned there was that not only is the market internationally really huge for uncrewed systems, and still, by the way, very early, in spite of the fact that drones and uncrewed systems have been around for a while, still a very nascent market, especially on the commercial side. I'd say military have been using drones and uncrewed systems in some form or fashion for many years, but even there, the growth is really there's opportunities there. One of the things that we really are embrace is how do you use this technology to sort of better the world? And one of the meetings we had there was around sustainability, and and sort of the doing things around that. So one of the things we want to get into, which we started to in Australia, which is surveying, for example, forests and things like that, and understanding the footprint and how carbon sequestration and all that stuff plays a role in climate change going forward, or improving climate change, I should say.
Yeah, I think methane detection is another really interesting example when you think about the environment and climate change and sustainability. And yeah, I think the vehicles themselves kind of lend, kind of a hand, if you will, to a sustainable future, by reducing carbon emissions and things like this. So it's a really interesting mode. I know we like nerd out sometimes. That I just did that PBS special on drones and eVTOLs, and had some of my friends here, and they're not in the industry. And the interesting questions I got were around battery technology. Like, well, isn't it true? Like you guys say this is sustainable, but there's still batteries, and don't they like dig into the ground and like, aren't those like rare minerals that we're using for the batteries? And I'm like, well, there's so many developments in the pipeline, whether it's hydrogen or, all kinds of things. So I just think the future is bright, and you're obviously a part of it. Now, when you think about, the military side of the house in particular, they have so many requirements. And, obviously on the commercial side, you've got certifications from the FAA. On the military side, there's certain standards and requirements that apply. And you guys actually attained, shall I say is the right word, ISO 9001.2015 certification. Can you explain what that is and why it's significant?
Yeah, sure. So, when you're working with the government, like you said, there's so many different requirements. It's very competitive, and one of the things you do on your journey is figure out what are those important certifications that will put you ahead of the pack. And ISO 9001 really speaks to process in your company and how you do things, how you document things. And so I felt that was very important to have as a initial certification. And there's a number of other certifications. For example, if you're building a piece of hardware like we are, and we, by the way, those drones you saw just earlier are all 3D printed. So we use additive manufacturing as a primary means, and it really allows us to prototype and build very fast and try things. Not to mention that the manufacturing process is a lot more flexible as well. But going back to your question on certifications, manufacturing certifications, the ISOs, those are important too, because you want to make sure there's reliability and safety built into the manufacturing process. So while we can build ourselves, we have partnered on the manufacturing side with an organization that essentially has been doing that for years, so that anything we produce comes out as a really good product.
Well, you talked about testing, and just to remind me, in the video, there seemed to be a couple scenes where someone seemed to be like in a big warehouse. And I remember at Edge, that's where that demo. So you guys have your own pretty robust facility where you can do this live testing and demos as well, right?
That's correct. Yeah, we've have a facility. We also we test everywhere. We have that. We have a flying cage with our partner, the University of Maryland, that we could use at any time we need to. It's the only flying cage, by the way. This is important. This is a small tidbit. Only place you can fly around the White House, the 25-mile nautical ring, legally. It's this flying cage where we are. So,
Really?
yeah, I didn't know if you know that. Yeah,
No.
and then we use other test facilities like X Elevate and other places like that, but those are outside the ring. So yeah, we have the only flying cage in the 25-mile nautical ring right near where we are.
So given that, do you also allow other companies to come in and utilize that because it is kind of uniquely postured?
Yeah, absolutely, we do, and that was part of the plan, was to be able to have other companies be able to use the facility as well. So yes.
Well, particularly if you're trying to possibly integrate your software maybe into their hardware, that
Correct.
makes an abundant amount of sense. Really cool. And by the way, you'd mentioned sustainability earlier, and I love your mission statement because it's really meaningful. can you kind of tell us a little bit about your mission statement?
Yeah, it's really around, I mean, just paraphrasing here, but it's really around how do we improve and save lives, right? And that can be done in so many different ways. That's a very broad statement, obviously, but where we can, narrow that down is some of the things that we mentioned or I mentioned earlier around surveying and mapping and methane, detection of things like that you mentioned as well. Those are a few simple things that can be done. I don't want to say simple because there is you're working with technology, so there's always something that can go wrong and something that can be better. So we're always trying to figure that out. On the other side of it is even what we see what we're seeing now in news every day, especially with drones and uncrewed systems, is around medical deliveries and things like that. So our autonomy, we feel, plays a role. So, for example, if we're delivering medical supplies to some mountainous region in the woods or something like that, our goal is that some of our technology makes its way into those pieces of equipment to be able to navigate and get to where they need to go, even if they lose GPS signal. And going back to your point about GPS, yes, a lot of people don't understand, even outdoors in cities, we call those urban canyons, where you're in a city and there's buildings all around you, and you try, if you've ever walked outside with your phone and said, hey geez, how come the maps, I got to go that way but it's telling me to go that way? It's because your GPS, your phone, has lost one of the satellites, and you need at least four, and you don't always have that. And so even like you said, what's happening in the news today with in drone warfare, for example, is GPS jamming, spoofing, etc., so that things don't get to where they need to get to, and it's important to be able to overcome that.
It's I can't foot stomp enough how important this is. I just started writing again for Inside GNSS magazine. I had done the Washington View for a while and kind of took a little break, and now I'm back in. But the Department of Transportation is really all in right now on finding what they're calling complementary position navigation timing technologies, because there's, I think, kind of an urgent awareness that GPS might not be the be all and end all. Everything relies on it, not just drones, like everything, like you said, even just getting in your car. It was a couple of years ago. I'm taking a trip tomorrow to Taos, New Mexico from here. And I remember a couple of years ago, I was going Sandia Labs from here, which is also kind of somewhat remote in New Mexico, 4-hour drive as well. And we were just relying on our little GPS navigator, right, in the car, me and this colleague, as we drove there from the Air Force Academy. And it dropped, the signal dropped. And we were in the middle of nowhere, okay, where do we drive right now? And I think it took us an extra hour because we obviously made a wrong turn and eventually the signal came back up. But I'm telling you what I'm doing today, Mode, I'm printing out my directions, right? Just to have them as a backup. But to be able to fly in complex environments and not have to have all your eggs in that GPS basket, I'm telling you, you are the future. And I hope people are listening, even people from the Department of Transportation, because I feel like your technology and your software, we're going to get into this autonomy here in a second. It's relevant, not just for drones, right? This can apply to other aviation modalities like advanced air mobility, not just drone delivery, but maybe eVTOL aircraft as an example, and some other things. So what you have there, I think, is golden, and the timing is right. So everybody, this guy's about a lot more than just hardware. So listen up, because let's get into that. Let's talk about the artificial intelligence, machine learning, and the autonomy that you guys have developed, not only for these drones but for other aircraft and other robots.
Yeah, sure. So if we talk about, if we use what we saw on the screen earlier in terms of autonomy, a drone flying by itself, or a self-flying drone, we'll call it. What you have there is you have your basic flight control software that most who are in the drone world would understand in terms of how the drone actually flies, left, right, up, down, etc. But then on top of that is another layer of exactly what you mentioned. Some AI, some machine learning, some non-machine learning, but we're talking about software algorithms. We're talking about software that essentially allows the flight control software to be manipulated, and you're doing that autonomously. So, for example, if I wanted to say circle around an object, for example, an object of interest. Let's say I'm the NYPD, and I see something of interest, and I want the drone to just fly around that thing and keep an eye on it until I get there or somebody gets
Or
there.
even like, look, you're just a rancher and one of the cattle escaped,
Absolutely.
and you've been able to locate this thing and you can circle around it while, kind of the cavalry comes to rope
That's
that
right.
thing up and get it
Right.
back.
And so in that example, you're essentially pressing a button, and that button is saying, "Okay, I found my object of interest. I'm just going to circle around this until you tell me to do something else." The other, um, the other piece of it is having what we call the robotic workload, or the robot taking the workload off the human, right? So, for example, we have had 9-year-olds, including my co-founder's son, as one example, coming into our warehouse and saying, hey, Evan is his name. He's 9 years old. Let's see if you can fly this drone. Well, gee, I've never flown a drone before. And within minutes, he's flying around like a pro, right?
Wow.
Kids are naturally better than us, older adults, at these sort of, manipulating drones and video games, etc. Anyways, but regardless, that's still a pretty neat, pretty great feat to be able to do that in just a matter of minutes and be able to, map an entire building indoors, without having ever done it before.
Well, that cognitive load you're talking about becomes, and lessening that on the operator becomes increasingly important in stressful situations. Just think battlefield, you're in the middle of some, kind of operation that could be life and death. As you said, law enforcement, depending on the scenario, same deal. Domestically, just so many different reasons why the ease of operation and decreasing that cognitive load on the operator means a lot in today's world. What I want to do, Mode, if it's okay with you, is let's pop up a picture of the Minotaur. I wanted you to talk a little bit about this drone, and then what we're going to do kind of is walk through all of these features you're talking about, the AIML, the different levels of autonomy in the context of this drone, and then we'll kind of parallel it with maybe incorporating that into other vehicles. So tell me a little bit about this Minotaur. I love this picture, by the way.
Yeah, thank you. So the Minotaur is essentially a quad, as you see in the screen, and it is designed, as we talked about earlier, to fly anywhere. One of the things that we're doing right now is you see on the screen, you see is sort of if you see the nacelle there, it looks like it's tilted kind of near the top of the screen. So those nacelles are designed to be thrust vectoring, meaning now you've turned your quad into essentially a VTOL hybrid drone that now can not only fly like a fixed wing to some extent, but also, take off and land vertically just like a quad would. But in addition to that, the entire aircraft then becomes a gimbal. So you don't need another gimbal hanging off of it. We've gotten to a point where we've created a digital gimbal where you've got a camera mounted and you're able to scroll up and down and get essentially everything you would need in your field of view, like you would with a traditional hardware gimbal, but doing it all digitally. But now, in addition to
That's a big deal too, honestly, because I'm not going to mention the manufacturer, but those hanging down gimbals, they're very easy to break. The cords to connect them, once they kind of disconnect or get jacked up, yeah, I mean, you might as well just throw the thing away, because it's going to cost you almost just as much to fix it as it would be just to get a new one for some of these.
Absolutely, absolutely. Yeah, so here with the thrust vector, we've actually turned the aircraft into its own gimbal as well. And then we do, when we do have when we get to it, I know we have one more picture here that sort of shows the components of the Minotaur. If we want to put that up,
let's pop that up.
I can talk that a little bit more there. Yeah, so very right, because of the 3D printing, the additive manufacturing ability, we've created a very modular vehicle. So we can put different types of payloads on, from a 2D LiDAR to a 3D LiDAR. So we're mapping, being able to map. LiDAR is a primary sensor of this vehicle because of the ability, so it gives it the ability to be able to operate in GPS denied environments. And then we're fusing that together with vision and other sensors to give a complete picture. In addition, as you can see, the little silhouettes around the drone, the idea there is to show you the ability to put different types of sensors on board, whether it's a chemical sensor or whether it's a thermal or infrared, etc. as well. And so it gives it quite a bit of versatility in terms of it's a our approach is a little different from the off the shelf type of drone that you might find like a DJI or Skydio, which are really very good drones. But we're sort of giving our clients a little more versatility. What we hear over and over again, especially from enterprise clients that are out in the commercial sector doing different things, inspections and whatnot, that, hey, we've got a stable of drones, but they can't all do everything. And so we're looking for equipment that can do things that are very specific and in specific environments. And then that's where we get a lot of traction, with those type of conversations, because they're essentially getting something here that they can use in different environments and also, have something that's more versatile than just the off-the-shelf drone.
Well, and on the military side, of course, we both know, and maybe some of the folks out in the audience, which, by the way, everybody, we are live, so say hi. We know you're out there. The military has really gone to this MOSA, or modular open systems approach, which you've kind of built and baked into your design purposefully. I think it's a brilliant approach, not just for the versatility, but for really, when you think about it, that longevity of being able to kind of upgrade the drone over time and not have to invest in an entire new, in the military side, program, or on the commercial side, like entire new like system. So I want to talk about the levels of autonomy, and I think this is really important because you've got a very high level of autonomy in this thing, as we discussed. 9-year-old can push a button and start flying it to map things, which is amazing. And by the way, I did see Evan, I think you said his name is, on LinkedIn doing just that, which was so cool. I think we have a slide to talk about the different levels of autonomous decision making. Can you kind of walk us through this?
Yeah, absolutely. So, I think autonomy is commonly misunderstood, right? So we like to differentiate automation versus autonomy. And automation is I can press a button and single task gets done. Autonomy is now there's more thinking involved, and the robot is actually making a decision based on a certain set of rules and can make multiple decisions, not just that one task. And so we break down autonomy into really 3 buckets, especially and this is in the context of a drone or an uncrewed system. So the very first being sense and avoid, which I like to simplify as, hey, just don't hit anything. You mentioned the cognitive workload earlier around taking that off the operator, and we hear that over and over and over again with from our especially enterprise clients, and I mean dual use government as well, but that, hey, you've just taken off 80% of the workload off of my operator by giving me these characteristics and features, so that they can just focus on the mission and less on the flying. And essentially, what happens is in the world today is you sometimes have more than one individual. You have a pilot and you have a payload operator, and companies would really like to reduce that head count. As much as we'd like to see more jobs, they do want to reduce that head count to make sure they get an ROI by using the drone.
Well, not only that, Mode, but think about it, right? The future is one to many. It's
Right.
one pilot to many drones. And if you've already been able to reduce that workload on the one pilot for one drone by 80%, do that math. I'm not going to do that public math right here. If it's multiple drones, that's awesome, because you're going to need that level of autonomy to be able to control multiple things at the same time, and be able to watch things and not have to actually be manipulating things constantly across the board.
That's right. That's exactly right. So in this picture here, we've got three levels. The one being sense and avoid, which means, hey, I'm going to have collision avoidance. I'm not going to hit anything, and I'm going to, maybe if I'm going into a building and I might autonomously just center down the hallway unless somebody tells me I need to get close to the wall for whatever reason to look at something. So those are some examples. And then the second bucket is really around the navigation. And there's a little more automation here where, like we were talking about, orbiting a target or doing a switchback on a wall if I'm inspecting something, or going into a tunnel. I can literally hit a button that says, I'm in a tunnel, and then the drone sort of situationally says, oh yeah, I see sort of this cylindrical type of thing. Yeah, I am in a tunnel. Let me fly now a certain way to fly down that tunnel. And then finally, the last bucket is the really what I call the more intelligence or smarts, which is now, you've been put an AI layer on board to detect something, or the drone knows that, hey, I'm going to run out of battery. Let me get to where I need to get to, or let me go home because that's what I was told to do, or what have you, and just make those decisions. Or, hey, I got to go home. I'm going to plot the fastest path back, and maybe I'm not going to come the way I came. So those are some intelligence things that I would say in the last bucket are examples.
Yeah. So obviously that you're able to do more with less people. But that last example is a great example, because I think the average drone that you're buying off the shelf, they're going to have a return to home button, and that's going to go wherever basically you took off from, or wherever you programmed it to, right? I mean, one thing I learned in my Part 107 class is, like, yes, you can fly from a boat. If you fly from a boat, you probably want to be on land, hit the return to home, like, kind of location button pin on the land, and then get in your boat. So it doesn't just, who knows where it's going to land, in the middle of the lake or whatever. But that's the point. You have to be either very deliberate about that, and there's no functionality for the drone to make its decision and say, I'm going to take a different and safer path than the way I got here. That's awesome. I didn't know it could do that. Very, very cool. So I mean, we kind of alluded to it, but let's kind of dig a little bit deeper into some of these military use cases, because you said you worked with the Air Force, you were over in Israel, kind of testing with the IDF. What are some of the use cases of the Minotaur in particular, or your software, that the military has employed?
Sure. And before I go into that, I'll one example that you just kind of made me think of is the return to home button. So we've had operators that other OEMs that build drones have said, hey, when we hit the return to home button, there's no guarantee we won't hit anything. Meaning that the operator, the pilot, still really needs to pay attention. So that's where our software can come in handy, where we integrate with their drone and give them some collision avoidance in whatever field of view is important to them, so that as the operator pilot is flying home and they've got it on, essentially autopilot, that if it does see something in its path, that the drone will automatically go around it, or at least notify the operator that, hey, I see something, what do you want to do? Right. So there's so that's one example, just kind of just to build off what you just said.
Well, and it's an important safety feature, not only on the battlefield, because one of those things drops out of the sky, it hurts a bunch of civilians. That's just a tactical blunder with strategic impacts, right?
Yes.
But with drone deliveries, that's all it's going to take is one time, for whatever reason, a glitch occurs, this thing's going, returning to home, and it winds up in a bunch of power lines, takes out all the electricity in a whole sector of the city. You're never going to hear the end of that.
And by the way, we do have a product for that. We call it the CRAB. It's the Collision Reduction Avoidance Black Box. So it's essentially
we can put on a drone. Incorporate the Maryland crab into your.
There you go. So I wanted to make sure I brought that up because of the crab. Yeah.
I love that. I love that. Well, tell me about, let's talk a little bit about the military use cases that have been successful thus far. And then I want to talk about some of these commercial side ones, and I will pop up a picture when we get to the commercial ones. So go ahead and tell us about the military side first.
Yeah. So, the military, just as you pointed out earlier, is very interested in GPS denied technologies, right? Yeah. Because it essentially, and by the way, GPS is being used as a weapon. And when I say used as a weapon, I mean denying GPS is being used as a weapon everywhere. In fact, Even in manned aviation, which I have a fairly good background in, they are jamming. I don't want to scare your audience, but they are jamming. People are jamming airline cockpit GPSs, right? So
Well, look, it's inadvertently happening. I
yeah,
just wrote an article where I think it was Bulgaria and Romania. I think it was Bulgaria and Romania, because of the Russian suspected jamming, that it was impacting commercial, aviation. And in fact, I think the FAA put out a notice to airmen,
they did.
or the notice, whatever they're calling it today, air messages, or
Notice
uh, I
air
know
mi-
it's
air
using
mission,
names to
air
be more
mission.
inclusive, and I want to be correct, um, around Israel.
Yeah,
No, actually, we were just talking on the full crew. Yeah, I'm sure they did around Israel for sure, but that's an obvious one. But we were talking about the Dubai Air Show Monday on the full crew, and there's a big notification on the Department of State website that the FAA has issued a NOTAM
that's
in the
right.
UAE and around the UAE because of the kind of the disruptive forces happening in the Middle East. So yeah, it's a reality. It's happening every single day.
Yeah, it's in the U.S. It's global, and yeah, the old NOTAM or Notice to Airmen is now Notice to Air Missions is the new
Thank you.
terminology. Yeah.
Very, very good. All right. So military side, obviously the GPS denied is important, but are we talking about things like personnel recovery, which is kind of akin on the civilian side to search and rescue, but on the battlefield? What other kind of features? Mapping, all of it?
Yeah, all of it, I would say. But yes, that's correct. So personnel recovery is one, but also just the ability to get into, I mean, we talk about this on the civilian side too, but even on the military side, it's essentially the same. The ability to go into an enclosed environment or a confined area and not have to put somebody in harm's way first,
Like a
right?
cave in Afghanistan.
I'm sorry, say that again?
Like a cave in Afghanistan. I mean,
Absolutely.
there was a lot of cave hunting going on for years after 9/11.
That's right. Caves, tunnels, buildings, you name it. The ability to get into those environments, and autonomy is very important to them because they want, again, that load off the operator, get into that setting, make it happen as autonomous as possible, and get that information, whatever that data is, whether it's a visual, whether it's a map, to get that data, depending on the mission, you might want one or both of those things.
Yeah, absolutely. And as you said, very similar on the civilian side. In fact, I think we have a picture here of some silos, some tunnels. I think I've seen this before, Mode, because I believe 2 years ago you were on a panel at the Energy Drone and Robotics Coalition Summit that I moderated, talking about the use of the Minotaur and your technology in an energy kind of type setting. And here's some examples. Can you
Yeah,
walk us through some of these?
yeah,
Yeah.
absolutely. So some of these examples that are on the screen really are there to demonstrate the austere environment. For example, on the far left, that's a wind tunnel. So wind tunnels are used to test structures like airplanes and cars and things in their environments, and you can really simulate a lot. But essentially, they have these big, huge blades, as you see on the screen
Yeah.
there. And so, we were flying around those blades, inspecting them and doing it essentially autonomously. The pilot can, by the way, when I say autonomous, what we've done is built the best hybrid, what I think is the best hybrid, meaning the pilot can still manipulate it. They can still fly it. They just get a lot of things that help them and that assist them so they don't hit anything. So you can still fly the thing or you can do it autonomously. And then, as we go to the right, that's a tunnel that's about to enter a tunnel there. It was actually in a tunnel. It's doing it again autonomously. We've essentially pressed a button and said, "Hey, let's go down. Let's go down this tunnel and see what we see." And then the next picture is a silo. So again, a cylindrical object. For those of you that are listening that are pilots, you'd probably agree that trying to fly in some of these environments, completely first-person view, would be almost impossible, and you'd probably hit something. And then the far right picture is actually outdoors around a cell phone tower, where you may think that's not a big deal, but we were doing it autonomously. We were pressing the button, and it was essentially, we had set parameters to say, every 1 meter circle, take pictures. Go up 1 meter, circle, take pictures. And so you're, again, doing this autonomously. And if you need to take over and change something or tweak something, then you do it. And that's, so it's really a hybrid. Design is best of class for both the pilot to control it, but also have autonomy features to really help them out and get the mission done faster and more efficiently.
That's awesome. And I know you've got this really cool, going back to the crab theme, horseshoe crab looking drone. That's more of a counter drone thing. We talked about that before. I don't want to talk about that because I feel like the new thing on this show that you've really highlighted, and I hope everybody's listening, is this idea that your software is plug and play and integratable with other people's drones and robots, and all the functionality that would bring as additional layer on top of whatever else they've got going on. So as we look forward, we're at now towards the end of 2023 already, which I can't believe. As you look forward to 2024, is this going to be a big line of effort for you, Mo? This idea of, hey, we've got software, guys, like, don't forget about that too.
Absolutely, yeah, it is. And while it sounds plug and play, and the idea is that it is plug and play, the reality is when you're working with hardware, there's always some integration involved, right? So there's some effort at the beginning to figure out what we're working with. So and different drones use different systems, like Pixhawk or this, or Cube and things like that. And so being able to work with all these, and also understanding the geometry of the drone and where things could be placed, the size. So it's really an engineering effort that once you do it once or twice with a particular manufacturer OEM, now is much easier to replicate over and over and over and over again, right? So that's the idea, yeah. So the 2024 effort is really around that, exactly.
That's exciting. I think we're going to keep seeing big news. Anything else as we look kind of into the future as to what we can expect from Airgility going forward?
Yeah, I think what we've seen and what we've heard is that we are ahead of the pack when it comes to AI and autonomy, and we plan to continue to keep developing to stay ahead of the pack, and create these things that really help all these. And I'll just back up 1 second too, and just say, outside of just Airgility, I do believe we are in a revolution and an evolution of aerospace technologies, both with uncrewed systems, space technologies, manned aviation as well. And so it's exciting to be a big part of that. And I think the AI autonomy can be used in different settings, not just uncrewed systems. There is obviously some effort involved when you're going into space, other efforts when you're going into space, or you're putting something on a manned aircraft as well. So or a crewed aircraft, I should say. So yeah, we're excited to see what the future holds with our software, and to continue to develop that.
Well, and we talk about AI all the time on the Full Crew, and spoiler alert, everybody, we're gonna have a big announcement next month about rebranding, if you will, the name of this podcast, because we're actually going to have an AI company on next week. But this show, as you know, Mode, is a lot more than just drones. There's a whole ecosystem, and when you think about AI in particular and how it's being incorporated into almost everything, and now what we're seeing on the policy side is White House putting out AI policies, OMB, on the federal side. So, what you're doing and what is happening on the policy side, always lagging behind. It's going to be interesting to see, because we talked about standards and certifications, how that all evolves. But you are ahead of the pack, and you have a voice that I think can maybe help lend some reason. So I hope you can get involved in some of these standards bodies and efforts. I know you're busy on the kind of the design and production side, but given your experience, I hope you can plug into some of that as well. But in the meantime, excuse me, still sick from my Las Vegas trip. It's only been almost 3 weeks. Yeah. In the meantime, everybody keep an eye on Pramod, keep an eye on Airgility, because big things will be happening. Speaking of which, while they're keeping an eye on you, where might they find you, like, looking into next year? Are you going to be at AVSI Exponential? What kind of other shows might you frequent next year.
Yeah, absolutely. We're usually at the big ones like UVSI and Commercial UAV Expo and different, the different industry conferences. But in addition to that, I think, we're starting to get more into the what I would call vertical specific conferences. Whether it's energy or oil and gas, we're looking at all those types. Energy Drone Robotics Summit is definitely a good one. You get a nice gathering of from especially the oil and gas and energy sectors down in Houston, and so we plan to be there as well. But yeah,
Awesome.
we're taking a look at all that now to see where we could be and where it makes sense to be.
Well, good. I'm looking forward to seeing you at some of these, and maybe even as a scholar for my Law Tech Connect workshop. We're going to have an AI panel this year, so we can talk about that more offline. But if people aren't going to these events, or even if they do, besides that, how can they find you? How can they reach you?
Yeah, absolutely. Pretty easy to reach me. You can go to my website and fill out the contact, or you can reach me directly at my email, which is really simple. My first name Pramod at airgility.co, not com, but co. And I'm on LinkedIn. I'm on Facebook. I'm on Twitter. Pretty much all the big platforms. So pretty easy to find me.
Well, awesome. Well, thank you so much, Pramod, for taking this time with us. I learned a lot. I have a whole new kind of vision about what it is you're trying to achieve, and not just on the hardware side, but on the software side, to make autonomy possible across the board. Really exciting on both the military and commercial side. So wish you the best. Happy holidays. Those are all coming up here. Have a wonderful end of year, and of course, a prosperous 2024. Everybody, we are out here.